This short slideshow will provide an introduction to earthquakes. The first very important point to make about earthquakes is that they are not at all rare. In fact, earthquakes occur every day with a frequency that's inversely proportional to their size or magnitude. The bigger the earthquake, the less frequently it occurs. The size of an earthquake is quantified with a value called its magnitude, which ranges from near 0 to a little more than 9. Earthquakes with a magnitude less than 5 rarely produce damage, while those with a magnitude greater than 6 almost always do. This slide shows how many earthquakes with magnitude greater than about 2.5 occurred in the week ending March 2nd, 2014. Notice that there were a lot of them. The colors correspond to when the earthquake occurred. Red for earthquakes that occurred within the hour in which this slide was made, orange within the day, and yellow within the week. The size of the circles corresponds to the magnitude of the earthquake. Here are all the earthquakes that occurred within one day of March 2nd, 2014. And once again, the point is that lots of them occurred, including some of them in North America. Well, what is an earthquake? Here's a formal definition. It's a short-lived episode of shaking or vibrations produced when blocks of rock suddenly break and shift. The shaking produces energy which propagates away from the source as seismic waves. The actual period of shaking can range from just a fraction of a second to, in the case of the largest earthquakes, many minutes. But typically the period of shaking lasts just for a few seconds. The second very important point to make is that earthquakes do not occur at random locations on Earth. Instead, as you probably would have predicted, they occur mostly along plate boundaries. This is a map showing all the earthquakes that have occurred within some period of time, probably a couple years on Earth. And this is a map of the plate boundaries. So once again, these are the plate boundaries, and here are the earthquakes. Earthquakes, plate boundaries. And you can see that almost all earthquakes occur along plate boundaries, which in fact was how geologists were able to infer the locations of the plate boundaries. In addition to their geographic location, earthquakes also occur near the surface of Earth. There's a reason for that. As you go down into the Earth, it gets both warmer and the pressure increases, and both of these conditions tend to make rocks bend instead of break. Since earthquakes only occur when rocks break, earthquakes cannot occur at depths where temperatures are too high and the rock tends to bend instead. This slide shows the results of deformation experiments done on a column of rock. The column is shown on the left, and the results of the experiment at low temperatures are shown in the middle, and the results of the experiments at high temperatures are shown on the right. And you can see that in the middle the rock has broken when the temperature wasn't too high, and on the right the rock has instead simply deformed by bending. The temperatures corresponding to this transition between breaking and bending is about 250 to 450 degrees C, depending on the actual type of rock. And the depths that correspond to these temperatures are around 15 to 20 kilometers. So at a depth of about 15 to 20 kilometers, rocks change from behaving in a brittle fashion, that is where they break, to behaving in a ductile fashion, that is where they bend. Here you can see this effect in action. I've plotted earthquakes at two locations in California as a function of depth going down. Each dot represents an earthquake hypocenter. You can see that almost all the earthquakes occurred at depths shallower than about 20 kilometers. And this depth is called, therefore, the brittle ductile transition zone, because it marks the change from brittle to ductile behavior. Earthquakes only occur in the brittle regime above the brittle ductile transition zone. There's one exception to this rule, and it occurs at subduction zones, which are shown as sort of the sawtooth patterned plate boundaries on this map. In fact, almost all of the deep earthquakes on Earth occur there. At subduction zone, earthquakes can occur really deep as perhaps 600 kilometers, though most of them don't occur quite that deep. The deep earthquakes mark the descent of the downgoing tectonic plate and define an inclined zone of earthquakes called the Wadati-Benioff zone, after the two seismologists who first discovered it. Although these deep earthquakes are uncommon, they are important because they are the largest earthquakes on Earth. This map shows the 16 largest earthquakes ever recorded as of 2012. Every one of them occurred beneath the subduction zone and was a deep earthquake. Some of these earthquakes are notorious because of the damage they produced, and some of you may even remember them. The 2011 Japan earthquake, for example, which produced the giant tsunami. Almost everyone remembers that one, and many of you probably also remember the great 2004 Indonesia earthquake, which also produced a tsunami. Since earthquakes occur when rocks break, they are intimately related to faults. In fact, the motion along faults is what creates earthquakes. Earthquakes are due to episodic movement along faults. Instead of sliding smoothly and continuously, blocks along a fault tend to stick and grab and then suddenly move all at once, producing an earthquake. This sudden breakage in movement is what causes earthquakes. This cutaway block diagram shows the terms used to describe earthquakes. The slippage starts at a certain point underground called the hypocenter, also called the focus. The point on the surface directly above the hypocenter is called the epicenter, and since it's on the surface of the Earth, it can be shown on a map. The fault plane is the surface of slippage, and the fault trace is the intersection of this fault plane with the surface of the Earth, which produces the line. The rupture surface is the actual area on the fault plane that slipped during the earthquake. Real earthquakes are more complicated than that simple diagram. Here's a real earthquake slip plane from an earthquake in China. On the cutaway of the fault plane, you can see the slip vectors, and the amount of slip is also contoured and shown in shades of blue. Notice the slip on this fault wasn't simple or uniform, and that's typical. This is typically what a real earthquake fault plane looks like. Beyond the rupture area, the rocks didn't break, but they undoubtedly deformed somewhat elastically. The rupturing of the rock produces energy in the form of seismic waves. There's a separate slideshow that explains the different kinds of waves. Some of these waves are body waves, like the P&S waves, which means that they can move throughout the Earth, and some are surface waves, which means that they travel along the surface of the Earth. The seismic waves radiate away in all directions from the earthquake source. To display how the waves propagate, seismologists can either describe them in terms of wave fronts, much like the series of waves that radiate away from a pebble dropped into a pool, or as ray paths, which are lines perpendicular to the ray fronts. Here you can see body waves, which are propagating into and through the Earth.